Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode, we're going to talk about NASA's Orion spacecraft. We have already looked at Boeing spacecraft, so we must also look at NASA's spacecraft. So first, you have to understand what happened with NASA. Basically, NASA put all their eggs into one basket known as Space Shuttle, and the idea with Space Shuttle was that it will be cheaper and better than Apollo system. Apollo system was very successful and it did what it's supposed to do, but it was expensive. Now, when Space Shuttle was created and at the end of the project life, people realized it failed on every single front. It's supposed to be cheaper, it was not. It's supposed to be quicker, it was not. It's supposed to be safer, it was not. So in every single way it failed, and it also had a poor capability compared to Saturn V system. So it failed drastically. Like, it was a quote unquote disaster, and not to mention there are like loss of life also happened, so that doomed the project. So after that, people needed a newer option but safer one, because you have to understand a space shuttle can carry more astronauts, but that also means whenever something bad happens, lot of astronauts die at the same time, so that is a very tangible risk. So new safer option was selected, and a whole rocket system was built, because space shuttle, people really did not like the idea of putting something parallel to a rocket, because if something goes wrong, well, you did. So they wanted to put on top of it, basically going back to the design of Saturn V era. So a new craft that was meant to be created, it had one different aspect compared to space shuttle. Space shuttle was only a low earth or orbit capable stuff. It was only designed to go into low earth orbit. Basically, even if you can somehow put basically more fuel or refuel in orbit, it was not designed. Basically, the radiation shielding and the power systems were not designed in such a way that you can carry it to the moon, even just to orbit. So this time, the craft that was meant to be designed, it has to much higher goals compared to space shuttle. It was meant to go to Mars, to moon, and to low earth orbit, basically international space station. So much broader kind of scope for this system was chosen. So that created the Orion project. Now in Orion project, the whole design was simple. Go back to the roots. No hoo-ha, no extra who try this or try that. Like, just take Apollo, make it bigger. That's it. And given the fact that it was designed from ground up rather than, like, adapting to another rockets, the diameter was much bigger. So benefit of that, it became a quote unquote upgrade to Apollo capsule. It is much bigger from the inside, so to say, and it is a multi-purpose crew vehicle. So you have to understand, the simplest, most common use that you will see recently would be carrying astronauts from American soil to ISS. Second use would be carrying astronauts from ISS or from directly from ground to moon. Third would be basically either from moon or from low Earth orbit directly to Mars. Now, be mindful, whenever I'm saying this is going to go to Mars, I do not mean as people will be in it. It will be basically docked with some bigger vehicle. So the idea would be there would be a maybe a below airspace kind of scenario would be there, where they're going to have inflatable modules or things of that nature. But this will not directly carry astronauts to Mars. Basically, that would be insane. So the idea is this will be designed in such a way that it can have the radiation shielding, the power electronics, everything that is needed for extended duration. This will have that, from communication to weather control to climate control and all that jazz. So that's the whole point of this. Now I'm talking about design, time and time again. Now you have to understand this in one simple way. You take the diameter of basically Boeing, SpaceX, both of them are small compared to this. This is from day one was built as a much more capable capsule design than there is. At this point in time, these three will become basically America's space capsule, so to say. And all these three are bigger than Russian option, and this puppy is much bigger than all these two combined. So that's the whole reality of it. It is built as a very capable thing. The living space inside it is only smaller compared to space shuttle. So that's a very big thing. On top of that, because again our electronics have improved drastically, and miniaturization of computer parts have successfully been attempted, so it's a very roomy, simply because all the avionics are much smaller, and it's also very automated. Yes, astronauts can any moment in time override it and take control manually, but they don't have to. And not to mention, even if they have to, the system is much more efficient, much more basically compact, so to say. So, and from day one, because it was designed for much broader mission environments, it has multiple configuration. Basically, if you want to send two astronauts to ISS, you're not gonna put a bathroom there. But if you are gonna take this to low Earth orbit, then dock a lunar lander, you're gonna make sure you replace some of the place and put a bathroom there, because it has been designed in such a way that it can accommodate those kind of scenario. I have provided the video down below. You can see that. So if you're going to moon, basically, which is multiple week kind of scenario, well, you must have a bathroom, so to say. So it's designed in such a way that it can accommodate low Earth orbit mission, lunar missions, and Martian missions, depending on what they will need, how many crews they have to have, how much storage space they should have, how much redundancy they should have, is designed with that way. And the seats are designed in such a way that they are folding. This was one thing they learned the hard way, that Apollo was very brutal on the astronauts, so to say, because they did not have comfort even in 0G, because the space was very cramped. It was not cramped simply because, like, they do not have space. They will be floating, so they do not need much space, but they need something not to obstruct it. Chairs were obstructing it. Here they learned from that the chairs are designed in such a way they can fold away, they can put their suits away, everything designed in such a way that we will get a small volume that is completely free of obstruction. So that will help you relax properly. So it will basically reduce fatigue on the astronaut, which is very necessary if you are pushing them to, like, multiple week missions, so to say. So designs is basically you take whatever worked and you just make it bigger. Now, again, these are design hoo-ha and all that. What about testing? Has somebody actually built it? Well, this is one thing you have to understand. The sole reason why USA is so behind in basically creating a backup to, not backup, basically a replacement to space shuttle, was simply because the original project that's supposed to replace it was called Constellation Project, and it had the same basically things as SLS. Now, Constellation Project was cancelled simply because during Obama administration, they looked back at it and it's like, okay, it is ludicrously behind schedule and it is ludicrously over budget, and it cannot meet the deadline no matter what they do. So the project was cancelled. So they cancelled they had supposed to have two launch vehicles, those were cancelled. However, this Orion system was way it was on schedule, so to say. So it was not scrapped. So they are like, okay, let's continue this project. So you can understand the original testing with physical hardware began as early as 2009, and basically launch abort testing is already done, and it actually went to space in 2014, basically the thing that Boeing did now. So you get the idea, like, it's been in development for a very long time. So it has gone through multiple testing of multiple scenarios, multiple systems, who had all of those things have been tested. So it is behind schedule, definitely, but it's a continuous progress to that. Basically every aspect of the system has been thoroughly tested, and I mean real life tested, from escape motors to basically radiation shielding in space. All of them, those have been tested thoroughly. So what about the future of the system? Well, Trump has basically made an announcement that's like, okay, we're gonna land on moon by 2024. This is an absolute deadline. It must be met. It's like it's not like we want to go to moon. It's like we have to go to moon, and that is the deadline. Now, can it be done? Well, not by NASA. NASA learned it very early on that they are way too inefficient now. So the idea is they're gonna make the system, because this is already 98% complete. So they're gonna like, okay, we're gonna focus on the basic crew department, astronaut sides of things, communication side of things, but for the lunar landing side, somebody else gonna build it. And here comes basically Blue Moon project, so to say, and it is a partnership with Northrop Grumman. These sort of things have not been worked out yet fully in detail, so it may change at the last minute. So as of now, NASA is gonna take care of the crew aspect, astronaut aspect, communication aspect, and all that, and they're gonna provide the vehicle, but it's gonna dock with something that they had the capability to land on moon, because again, this cannot land on moon. So they're gonna have something from Blue Origin, hopefully. And this time the project is completely different. This time they want to establish a presence there. It's not like go there and come back. It's not a picnic. They want to create a research outpost, so to say. So the target is that over time they make it so that there is a continuous presence in the basically on moon, same way there is a continuous presence in low Earth orbit. So that is the end goal, and this end goal will begin from 2024, the moment they will have the first landing. So this whole system is designed much more thoroughly, much more thought out, much more planned. Apollo was a race, it was a space race, it was like a sprint. This is a marathon, so it has a bit more different kind of approach to it. So is it on schedule? Yes. The project basically Artemis is on schedule, so to say, quote unquote. Hopefully nothing bad happens in the next 2-3 years. So we can easily see a proper moon landing in 4K, 60 frames per second, hopefully by 2024. So this was my presentation on Orion spacecraft. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment. Please leave a comment because I try to reply to all of them. Share it amongst your friends, that will help me a lot. And subscribe, press the bell icon if you're free. And as always, thanks for watching.